between the two is the idea we can always convert from something that is not base E into something that is base E. And we don't have to go through the process of solving for it either. We can rely on facts. All right, we discover these facts, but then once we discover them, they become things that we can rely upon. All right, so f of x is the same, instead of 6, write it as e to the ln of 6. And you could use the shortcut rule for this, but I don't think that really does much in the way of delivering understanding. Anyway, so multiply your exponents, at least in the early goings. E to the 3 ln 6 times x minus 5 ln 6. So that's what f of x is equivalent to with a base e. All right, not as nice as the original form, or maybe not as concise as the original form, we'll put it that way. But differentiable, provided my pen wants to work. So derivative of exponential base e, keep it as is for the first go around. I have to write like slow like now because the iPad can't keep up with me. What's the derivative of the exponent? 3 ln 6. All right. And we know that this is the same as 6 to the 3x minus 5. Either form is okay by me. You know, free response question, perfectly fine either way. Multiple choice question, you got to get from what your answer is to the correct choice. And sometimes making that recognition is going to be important. But you know, if you got to this point in the process, at some point you made the recognition that 6 to the 3x minus 5 was the same as this, which was the same as that. So just working backwards should be easy enough. But again, the shortcut rule, the shortcut, right? So I think this is kind of shortcutty because we didn't actually show how the 6 became e to the ln of 6. But a shortcut even to that, which demonstrates really no understanding of calculus, but still it'll get you the right answer, would be rewrite multiplied by the derivative of the exponent multiplied by the natural log of the base. All right. And sometimes we do want to get stuff right quickly on timed exams, assessments, things like that. So there is a time and a place for that. But in the learning process, obviously you want to understand why things work the way they do. All right, number 2. We'd been working with natural logs. Now we have a log base 8. I mean, we could have a common log. We could have base anything. All right? The only thing we wouldn't really have is a variable base, at least not yet. So, change of base formula. Log base b of a. I mean, I wrote the a. Like, I don't, whatever. It's just not working with me today. Is equal to the natural log of a over the natural log of b. Nice little pre-calc rule there. Algebra 2 pre-calc. Same as 1 over ln b times ln of a. All right, so this is going to be good news, because what that tells me is that whatever the base is, I can incorporate that into a coefficient of the natural log of whatever the function is related to. So it was the log base 8 of 3x minus 2, so I could rewrite that as the natural log of 3x minus 2 as long as I make the original base part of the constant multiplier. All right, so in action, let me just show you. This would take the place of the b, and this would take the place of the a. So we could rewrite f of x as 1 over ln of 8 times ln of 3x minus 2. That's an equivalent log, or at least log expression, log function. And also, more importantly, something I can differentiate easily. So here's my constant multiple. No matter what form it's in, it's still a number. 1 divided by a natural log of 8 is some decimal value. I don't care what it is. I just know it's a number. So carry that down. 1 over ln of 8. Then I need to take the derivative. Blue, I think, is the color I'm going to go with. The derivative of the natural log, which is 1 over whatever's contained within the natural log, so 3x minus 2, multiplied by the derivative of whatever is in the natural log, so 3. And there it is. I mean, we could consolidate a little bit, but I don't see the point. All we're going to do is write it as 3 over ln of 8 parentheses 3x minus 2. That's pretty much the same thing. All right, so what do we get from this? The idea that if you have a log with a base other than e, so other than the natural log, take the derivative the way you normally would. Just make sure you multiply by 1 over the natural log of whatever the base is. Right? So you connect that to the case where you're actually finding the derivative of a natural log. You're actually doing the same thing. So if a question said something like, find the derivative of ln x squared minus 4, I could think of that as log base e of x squared minus 4 and use the same process. I'd find the derivative of this, so that would be 2x over x squared minus 4, and then I'd multiply by 1 over the natural log of the base. But 1 over the natural log of the base is going to cancel out to 1 anyway. So all you're left with is this. All right, so this is actually the more generalized form that allows you to find the derivative of any log, among which would be your natural log situation. All right, so we could generalize this by saying d dx, we have log base, doesn't matter what you call the base, I'll call it base b, of some function u, would be 1 over ln of b times u prime over u. Oh, my rectangle is so huge now, it doesn't make sense. It just feels all wrong. I over-rectangled. Now we're a little bit better. I went from like tiny writing and like jumbo size. Okay, so really just a small extension of what we've been doing.